A red ball A is fired along the x-axis, and simultaneously a blue ball B is fired along the y-axis, and both A and B travel along the plane of a table. So you can think of this as the top view. A is fired with a uniform velocity of 15 meters per second, and B is fired with a uniform velocity of 10 meters per second. There is no acceleration in either the x direction or the y direction. We have to find the velocity of B with respect to A. So we can think of A as being fired with a velocity of 15I and B being fired with a velocity of 10j in vector terms. In the problems we have dealt with so far, we have solved for the relative velocity in a single dimension, so we did not have to use vectors. Now we have simultaneous motion along both axes, but in order to obtain the relative motion, the formula and the principles would remain identical. By definition, the relative velocity of B with respect to A is the velocity of B with respect to the ground minus the velocity of A with respect to the ground. So at the origin, we draw the red vector VA with a magnitude of 15, and we draw the blue vector VB with a magnitude of 10. Now we have to perform a vector subtraction in order to obtain the velocity of B with respect to A. Let's do this both ways, graphically as well as using the formula. Graphically, how would we do a VB minus VA? So we first slide the tail of vector VA and place it at the head or tip of vector VB. But if we take the resultant at this stage, it would give us VB plus VA, but what we want is VB minus VA, or in other words, we want to add minus VA to VB. From VA, how do we get minus VA? We would have to rotate VA by 180 degrees. So let's do that next. Now we rotate VA by 180 degrees and we get minus VA. Now we can add these two vectors and the resultant would be VB minus VA. So this is VB with respect to A, which is VB minus VA. The magnitude of VB was 10 and the magnitude of VA was 15. So we get VB with respect to A as 18.02 if we measure this. Let's also do this mathematically. VB, VA and VB with respect to A form a right angle triangle. The magnitude of VB is 10 and the magnitude of VA is 15. From here we obtain VB with respect to A as 18.03 meters per second, as it is the hypotenuse of a right angle triangle. The angle made between the vectors VB and VB with respect to A will be the tan inverse of VA over VB, or the tan inverse of 15 over 10, which is 56 degrees. Therefore, the angle made with the x-axis marked as theta would be 90 plus 56 or 146 degrees. Now let's put a physical meaning to the vector VB with respect to A. The magnitude of VB with respect to A is 18.03 meters per second, and the angle with the x-axis is 146 degrees. This means that from A's frame of reference, A is assumed to be at rest and sees B moving away with a speed of 18.03 meters per second at an angle of 146 degrees with the x-axis. So to a person in the ground frame of reference, A is traveling along the x-axis and B is traveling along the y-axis, but A sees B traveling along a straight line at an angle of 146 degrees with the x-axis. And if you wonder how B would see A, then B would assume himself to be at rest or to be stationary and would see A moving in exactly the opposite direction of how A would see B, moving away with a speed of 18.03 meters per second. When two particles move in a plane, both with uniform velocities without any acceleration, then from one particle's frame of reference, the other particle will appear to be traveling in a straight line.